Hello everybody, welcome again. We're here with the third video of the series. So in this video I'm gonna talk about simulating the fluid flow on the ANSYS Fluent. But before getting into that one, I forgot to tell something in the Maxwell 3D. So if we open the Maxwell 3D project, we talked about these plots. So if we go to the 3D model over here, and make the region invisible and press Ctrl D to fit the model to view, and we can here we can select copper parts and right click and plot fields. So we can plot ohmic loss over here, EM loss plot on surface, and the frequency is going to be 20 kilohertz. Make the PCB disappear. The ohmic loss distribution across the geometry. So you can see that on the edges and on the thin areas we have more losses. So this is what I was going to show you. And in this plot you can see that for one of the tracks, the power loss is around let's say 2.5, 2.5, 2.5, 2.5, around 47 watts and 25 watts and 13 watts. So we can save this and close the Maxwell project. So now we can connect the geometry to ANSYS Fluent geometry and also the solution of the Maxwell 3D to the setup of the ANSYS Fluent. So we need to update it from here. Then we can go to meshing and start meshing our model in ANSYS Mesher. So we need to be careful in the ANSYS Mesher, because for the CFD analysis the meshing is very important, and so you need to consider a very suitable mesh for this application. So if it's too fine and if you perform a very fine mesh, it's gonna take a long time to analyze your model, and if you use coarse meshes, it might not converge. So you need to have a little knowledge about the meshing and stuff. So here's what I wanted. If I start meshing here and insert a sizing, and for the geometry I'm gonna select body and select the air chamber. Then I can select this and say hide body, and then I'm gonna add another sizing and select the board and apply. Okay, for the body sizing of the air chamber, I'm gonna change it to 3 to -2. That's gonna be 3 centimeters. and for the board I'm gonna set it to 4 millimeters for E to -3, and then I'm gonna select and hide the board. Then I'm gonna add another sizing, and for the selection mode I'm gonna select box mode and select everything and apply. And for the element size I'm gonna say 1.5 millimeters, 1.5 e to -3. And for the mesh in the sizing section, okay, not in the sizing here, in the element size over here, I'm gonna set it to 5 millimeters, 5 e to -3. Okay, then I can generate my mesh to see what happens. So I'm gonna need for my meshing to be done. Okay, I will come back later. Okay, our meshing is completed, so we can see our mesh over here. If I right click here and select show all bodies, you can see here the air chamber. And if I select, okay, so here in the statistics you can see that I have around 3 million mesh elements. So you can, if I select air chamber and hide body, and so these are the elements you can see here. So next we need to create name selections. So I'm gonna show all the bodies, and okay, so here I can select this air chamber and right click create name selection. I'm gonna press N for the shortcut key for this one, for the next name selections. So I'm going to name it to Floyd Air. Okay, and then I need to specify select faces. Here inlet, here is going to be top, right side, left, here should be bottom, and here outflow. Okay, so if I select this, okay, I'm gonna select bodies and hide this body. Then select this and name it to solid board. Okay, and select this and hide that body. Okay, then I need to select these guys over here, select box, select this one over here, then here, control key this, and name it to solid, going to be high loss. Okay, and then here in the name selections I can select this one and select items in group. And okay, I need to go to select solid high loss section and select items in group and right click hide body. Then I need to change selection mode to box select and select over here, then the other side, select control key, hold down control key and select this one as well. Let's check the other part, and press N key and name this selection to I actually did this one, I guess. So if I go here and right click, select items and group, this is solid white, and I can hide this body and then select everything else and press N key, the last name selection, solid low loss. Okay, now if I go and say show all bodies, then hide the air chamber and see my model again. Okay, I can now save my project and go to start ANSYS Fluent analysis. Okay, save project is in progress. Okay, now our mesh is completed. We can update the mesh and then start the ANSYS Fluent for our simulation. Okay, now we can double click on setup and it's gonna start ANSYS Fluent. Okay, we'll select 3D and double precision and increase the processor to 4 CPU cores and then click OK to start the ANSYS Fluent. Okay, Fluent is started, so I will change the units of the length to be millimeters, and also temperature in degrees Celsius. Okay, and then in the models I will turn on the energy equation. Okay, then for the materials, if I go to materials, I will select user-defined database, and then I will select the file that I exported from ANSYS iSpec. I will go to the project folder and then select Fluent materials.scm that I exported from. Okay, then I will go for the fluid air, copy a new air. Okay, and then for the solids I will select copper. I'll select pure copper, copy, and also FR4. Okay, FR4, copy and close. Okay, here I will delete. The materials that I don't need to. Okay, then I will go to fluid domain in my geometry, and then I'll change it to air new. Okay, and for my board, I will change the material to FR4. Okay, and for high loss solid, change it to pure copper. For the other two tracks, change it to pure copper. And also for the last one, pure copper. And for boundary conditions, in the boundary condition, I will select inlet, and I will specify 20 centimeters per second for the inlet air velocity magnitude. And here for the outlet, I'm going to leave it on the outflow type. Then last but not least, I need to go to the file EM mapping and set volumetric heat source. I need to change the frequency to 20 kilohertz, and the solid high loss, low loss, and wide. So then I'll click OK. So this will start running ANSYS Maxwell for getting the loss values. Okay, you can see here that the losses for the zone 18 wide is 13 watts, and for zone 19, which is low loss, is 24.5 watts, and for zone 17, which is the high loss copper, is 47.66 watts. So I think our model is ready to run, so I'll go to the initialization and hybrid initialization. I'll select initialize, and I need to wait for my problem to be initialized. So hybrid initialization is done. Then I can go to run calculation and change the number of iterations to development, and then I can click calculate to start analyzing my problem. Okay, we'll come back later when the solution is converged to see the results. Okay, here we can see that our simulation has been finished. So and you can see the convergence plot over here. So next we can plot a temperature contour. So I'll click on the contours, then I'll go to color map options, color map size, I'll make it to 40, and I'll make it to float, apply, close, and I'll draw a mesh. Okay, inlet, outlet, bottom, left, right, top, feature, display, Okay, so I'm gonna close this one. Then I will plot temperature, static temperature, and not global range. So I will click. So I will select everything but these four faces. Okay, then I will go to display and I will turn off the lightings. So here we can see that our maximum temperature so it's so tiny, I think you cannot see, but right now you can see that the maximum temperature is so maximum temperature is 418 degrees Celsius, and it is on the copper with high losses. So it is the result for the ANSYS Fluent. So okay, next I think that's all for this video. So see you on the next video. Peace out.
Tell me pretty lies, look me in the face. Tell me that you love me, even if it's fake.